everyone. Thanks for joining us today. We're going to be hearing all about ice sheets today, which is something I know nothing about, which I'm really excited to hear about. So here's how today's going to work. If you have a question, submit it to the Q&A, and then I'll ask Mike as we're going. As we go along. So just so everyone's aware, this program is run through Skype a Scientist. We're a 501c3 nonprofit that helps connect scientists to people in all the ways we possibly can. And so we've been running these sessions to try to keep entertained during this total bummer of a time. So we're a totally donation-driven nonprofit. And so if you can help support us, you can do that at paypal.me/Skype a Scientist, or support us on Patreon at patreon.com/Skype a Scientist. That's all the ads we'll have for now. So I'm just gonna let Mike take it away and introduce himself and tell us about all the cool stuff he does.
All right. Hello. Yes, my name is Mike MacFerrin, and I am a glaciologist by trade. So that means I study glaciers and ice sheets, and my main specialty is on the big ice sheets, on Greenland in particular. I've spent a lot of time there. I am, so we don't have any screen sharing right now, do we? Oh, I can't hear you.
Yeah, sorry, I muted myself. Sometimes my cat just screams in the background, but I will fix that because you will be able to scream.
Okay, I was just going to show a few pictures. In the meantime, so what I do for most of my time, sometimes we do go up to the ice sheet, and I've done half a dozen field campaigns in Greenland. It means a whole team of us will, here we are. I can share some pictures here. Yeah. So this is me on the ice or on the edge of the ice sheet in Greenland. There's over 200,000 glaciers around the world, and a glacier forms whenever snow builds up and then starts to flow under its own weight over time, and it forms into ice. The two biggest glaciers in the world are Greenland and Antarctica, and these are what we call the ice sheets. They cover entire continents with ice. And I'm standing next to an outlet glacier, this ice flowing out and cracking under its own weight on the edge of Greenland, the Greenland Ice Sheet. And we go, Greenland, here's a little map of Greenland. We tend to gather in this little town of Kangerlussuaq in the southwest corner of the ice sheet, and then we go up onto the ice, and we do all kinds of things when we're on the ice. We'll drill cores to pull up layers of ice underneath us. I'm actually standing on over a mile of ice. The ice is over a mile thick where I am. It does get stormy up there. We'll spend as much as a month at a time on the ice sheet, and taking measurements. We'll build instruments, and then we come home and use the data to discover what's happening with the ice sheets, because as the planet warms, they're changing really, really fast. It's a really curious thing to be out in the middle of the ice sheet. It's extremely beautiful, but also one of the most desolate places I've ever been. Here I am standing. We're over 200 miles from the nearest rock, and I'm just standing in the middle of flat white snow as far as the eye can see. And it's not just me that goes up there. Whole teams of us will go up to the ice sheet. And in this particular picture, we're sitting out in a really warm day. Sometimes it's not quite as warm where it'd be comfortable sitting outside like that. We tend to get around by snowmobile. We'll drive around to different camps in the ice sheet and set up camp, and then take measurements for a while, and then break down camp, and then move somewhere else. And when we're not on the ice sheet, I'm often preparing instruments and getting things ready to put on the ice sheet. This is a box with different computers in it that are taking measurements of things we put out in the snow and the ice, and then we go up to the ice sheet, and we install these stations and put them up there, and they take measurements through the whole year, and then they use little devices on the top that transmit out signals and send us data back home, so that when we're back home, I can be looking at the data and seeing what's going on the ice while we're out there. So this is what we do for a living, and the reason people care about places like Greenland and Antarctica, one, because they're just really cool, and it's very cool to know what's going on there, but two, because the ice is melting pretty fast, and it really matters to people around the world how quickly these melt, because it can raise sea levels. So that's it for now. I'm gonna unshare the screen here and let me get back to, yeah, um, stop share. There we go. Yeah, and then just open it up to question and answer. That's me in a nutshell there. As much as we give a lot of pictures of us out on the ice sheet, about 90% of the time at least, I'm just at home working on data or in the office writing papers about this stuff and looking at the data that we collect. So that's what I do as a glaciologist, and it's, I think, time now to open it up to questions.
Awesome. Thanks for showing us that. Okay, so the first question is, what do you use the data that you collect for?
Excellent question. So there's a lot of different kinds of data that we take out there. It's really expensive to get out there, so we do as much as we can in one trip when we get out there. And so some of the data, we're measuring how much the ice is melting on the surface. Some of it, how quickly the ice is moving. We'll put GPS stations up there, and it'll tell us how fast the ice is flowing. Because when we're up there, the ice is slowly moving under our feet out towards the coast. And it moves a lot faster in some places than it does in other places. Some of what we're doing is actually putting measurements that help the satellites measure the ice sheet. Because when we're out there, we can really only measure at one point at one place at a time. But the satellites can measure the whole ice sheet at a time, but they need some help. There's things we can measure on the ground that's going on with the snow that the satellite can't measure. And therefore, it helps the satellites and the folks at NASA who run these satellites get better measurements of what's going on across the ice sheets. So we're there doing what we call ground truthing, taking measurements for what the satellite sees, how they can interpret that from space.
Cool. So is there ever a danger of falling through the ice when you're up there?
In some places, that's definitely a danger. The ice cracks and it forms what we call crevasses, and these cracks can get 10 feet wide or more and can go down hundreds of feet. So if sometimes they're covered by snow and you can't see anywhere where these cracks are. And then it's a big danger of, if you're walking over one of these cracks, you could fall through the snow and fall into one of these cracks. And people carry crevasse rescue equipment where if you do fall in, that they can pull you out with ropes and things. But where we tend to go in the middle of the ice sheet, there aren't these cracks. The cracks form at the edge where the ice is flowing really fast. And when we're out there in the middle, there really aren't any of these cracks. It's just flat white snow everywhere. And so when we're driving around, we don't worry about falling through the snow, at least where we are. The bigger dangers are the cold and the wind and the weather and those kinds of things that can really get us in trouble.
Cool. So how did you first get interested in this topic?
Well, I actually didn't. I wasn't studying glaciers to start out with. I was an engineer studying computer science, and wasn't very happy doing it. I liked the kind of problems, but didn't overall like what I was working on, and talked with a professor at the university I was at who did study ice sheets and glaciers, and it turns out that my computer background actually was really useful for interpreting the satellite data. And there's a lot of data that these satellites pull down. And so being able to do all that stuff on the computer was really handy. And I ended up getting involved with glacier and ice sheet research, and then managed to get out with an international team that was run out of Denmark and England at the time, to get out onto the ice sheet for the first time and take some measurements out there on the ice sheet. And then we've gotten some projects funded here through NASA and NSF, the National Science Foundation, that have taken us back up there again and again to keep taking more of these measurements. So that's how I got into it. People come into it from a whole lot of ways. Some people study biology and they study little algae and plants that grow on the ice sheet. Some people do physics and geophysics, the way the ice moves and flows. There's a lot of different backgrounds people come into to do study on glaciers and ice sheets.
Awesome. So how have you seen climate change affect your work?
Climate change has been a huge issue, especially in Greenland and to some extent in Antarctica as well. The Arctic, that's way up towards the North Pole where Greenland sits, has been warming over twice as fast as the rest of the planet. And we see that with these bigger and bigger melt seasons in Greenland. So we'll get years when it just gets way, way warmer during the summer than it ever did before. And that's causing more and more and more melt, and it's causing huge changes across the entire ice sheet. And that's a large part of what we're out there to try and measure. If nothing was changing on the ice sheet, if it was all just staying exactly the same, there wouldn't be nearly as much need for as many measurements as we're taking. But since everything's changing really fast, it's really important for us to be out there and get these kind of measurements, and to determine what sorts of new things are happening there.
Cool. So where you're working, like how cold does it get up there?
So in the middle of the Greenland ice sheet, when we're there, we typically our campaigns, we got there in the spring, like in April or May. And when we get out there, it'll be anywhere from -20 to -40 degrees. Uh, it is cold. We're out there with equipment. We've got full body suits on. We have big, thick sleeping bags that we sleep in. I have boots that are rated in -100 degrees. And we'll stay out there for a month. It does get very cold sometimes. We try and be out there when it's not melting. We want to get there before the melt starts. That's why we go in April and May instead of July or August. Some people actually stay out there all winter. They don't camp. They'll stay in small buildings and stations on the ice sheet. But like at the summit camp of Greenland, they'll stay out all winter. And sometimes it gets down to -60 or -80 degrees in the middle of winter. It's pure darkness. Since it's up north of the Arctic Circle, it's dark all winter long. So it's like a one night that lasts for 4 months, and they won't see the sun for that long, and it gets extremely cold up there. So they have to take extra precautions when it gets that cold, with complete face masks and no skin exposed, or it'll freeze very, very quickly. So we have to be careful that it doesn't get quite that cold when we're out there, but -40, it's pretty cold. And when we're driving around on those snowmobiles, we have to be careful. We wear full helmets, and we've got all of our bodies covered as well.
That's wild. So how old is the ice when it's really, really deep? Like when did that ice originally form?
Excellent question. So generally on the ice sheet, new layers of snow form every year, and then the older layers get buried and buried. So the deeper you go, the older the ice gets. In Greenland, the deepest ice gets anywhere from 30,000 to about 80,000 years old. And in Antarctica, it gets much, much older. Antarctica is much bigger. The ice is older there. The oldest ice they've found so far is about, or at least at the bottom of the ice sheet, is about 800,000 years old. They have picked up little bits of ice that are almost 2 million years old. They're right now trying to drill a core in Antarctica to get down to the bottom of a spot where they think the ice is over 1 million years old at the bottom. And so they can detect what the snow was like and what the atmosphere was like in every one of these little layers as you go deeper and deeper and deeper, and it becomes a really great record of past climate.
Cool. Do any animals live on or near glaciers?
A lot of animals live near glaciers. When we are out on the edge of Greenland, like out in that first picture I showed you, when we're sitting on the edge of the ice on the tundra, there's lots of Arctic animals. Lots of reindeer live there. There's lots of muskox live in Greenland. There's Arctic foxes, Arctic hares. It's these rabbits that get really big. They're the size of small dogs. There's Arctic wolves that live up in North Greenland. There's a lot of animals and fish in the oceans. There's whales and narwhals and seals and stuff in the ocean and the fjords. On the ice sheet, there's not a lot that lives there because there's really not any food in the ice sheet. We will see birds there from time to time. Sometimes you'll see birds flying overhead when we're out in the middle of the ice sheet and there's no rock for hundreds of miles. When birds fly over, we notice them. Sometimes they're just migrating across the ice sheet from one edge of Greenland to the other. Birds do migrate. They'll migrate across oceans and they'll migrate over the ice sheet. Sometimes, though, one year we had a bunch of storms come in where we kept getting storm after storm, and we'd have to stay in our tents and couldn't go out and work because you couldn't see anything. It was completely white out. And birds, there was a flock of these small little birds these little brown birds that tried to shelter in our camp. They were out in the ice sheet, and they would start hiding under the tent flies and in the snowmobile, like under the dashboards of the snowmobiles, and we would find them around. Like I'd unzip the tent and there's a bird there underneath the rain fly, and they kept trying to take shelter in our camp. And so, yeah, every once in a while, because we were the only shelter there was in hundreds of miles in all directions. So that was an interesting experience.
Awesome. So what's the biggest glacier there is?
So it depends how you define it. The biggest piece of ice there is Antarctica, the Antarctic ice sheet. It's an entire continent covered in ice. And the way we define a glacier is typically it's when one piece of this ice sheet then flows down a valley and out towards the coast. And the Antarctica has hundreds of these glaciers that feed from it. Greenland also has hundreds of these glaciers that feed out from the ice sheet. And some of the biggest glaciers are in Antarctica, actually, because it's the biggest ice sheet. And so some of the biggest glaciers there, the Totten Glacier, the Thwaites Glacier, other gigantic glaciers that have hundreds and hundreds of square miles of ice behind them that feed into these glaciers. There's a lot of big glaciers, though, in other places. In Alaska, there's a number of ice fields. They're not as big as Greenland or Antarctica, but they have big glaciers that flow down these valleys. Maybe you've seen pictures of these glaciers flowing down between mountains. There's a lot in Argentina and Chile, in the Patagonian ice fields down in the southern part of South America. There's a lot of glaciers in the Himalayas, in Nepal and India and China. There's large glaciers that feed from those mountains. There's glaciers in North America. There's glaciers in the Rocky Mountains. There's Glacier National Park has glaciers. They're not nearly as big as some of the really, really big ones in other places, but they're there. They're also being affected by climate, and they're melting really rapidly right now. A lot of these small glaciers, some of them are disappearing. But yeah, the really, really big ones are where the big ice is, and that's in Greenland and Antarctica, are where the really big glaciers are, that just are miles and miles and miles wide. There's no way you could walk across one, and yeah, and they feed hundreds of miles of ice and icebergs into the ocean.
Cool. What tools do you use to study glaciers?
There's a lot of different tools we use to study glaciers. You saw me with a drill. We drill down and we pull up these cores that have these layers of snow and ice. So we use these drills. We use all sorts of measurements. We set stations out there that measure things automatically, like temperature, and they'll measure snow depth, and they'll measure all sorts of other things in the snow. We use radar. I will drive a snowmobile and we'll have a little radar on the back that sends down little radar signals into the ice, and it bounces off layers within the ice so we can tell what's underneath our feet in the snow and ice. We will use airplanes. I've done a lot of measurements from airplanes. NASA's had an airborne program called Operation Icebridge that flies over Greenland and Antarctica, or did fly over Greenland and Antarctica every year for about 10 years. And it would take all sorts of measurements from the airplane. So it could take pictures of the ice. It could take different radar measurements. It takes measurements of the height of the ice. And all sorts of measurements as it's flying over, and we use a lot of those measurements. And then finally up to satellites. The satellites will take pictures of the ice sheet. You can tell how much of the ice sheet is melting, where there's lakes on the ice, where there's rivers flowing off the ice, how fast the ice is flowing. All those things get measured by satellites. So we use a lot of satellite data, and they bring down a lot of data. And so it takes a lot of time to go through all that data and figure out what all is going on there. So it's a lot of different tools. Some people use seismics. They'll actually make little explosions on the ice, and then the sound waves propagate through the ice and bounce off the bed and bounce off other parts, so you can also tell the internal structure of the ice from that. There's a lot of different tools that people use. That's just some of the ones we use to measure when we're up there.
Awesome. So how thick is the thickest glacier?
So the thickest glaciers is kind of similar to that biggest glacier question. The very thickest ones are in the ice sheet. So when we're in Greenland, we're standing over 2,000 to 3,000 meters of ice. That's a couple of miles of ice. That thick. It gets even thicker in Antarctica. It gets up to 4,000 to 5,000 meters. So that's almost 3 miles thick of ice. And that ice is slowly spreading out under its own weight, because that much ice is so heavy that the ice, you think of ice as like a solid, like you could hit it with a hammer and it shatters into little pieces. But when it's under a lot of weight, it actually flows. It's kind of like a liquid, kind of like cold honey. If you put it on a plate, it'd slowly flow out away from you. That's what a glacier does. And so since snow keeps building up on top of these glaciers, the only thing that keeps them from getting just infinitely thick is the fact that they're flowing out slowly over time. So it's slowly getting thinner, and then new snow keeps building up and it slowly gets thinner. The surface more or less stays at the same height. And so, yeah, the very thickest ice is in Antarctica. So in the East Antarctic ice sheet, you'll get ice that's 4 to 5 kilometers thick. It's roughly 3 miles. In Greenland, it gets about 2 miles thick. And then all the other glaciers, you're talking about hundreds of feet or maybe 1,000 feet thick at the most, which is still really thick. You don't want to be under that. But yeah, most glaciers are on that border of thickness, a few hundred feet.
Do you ever participate in any snow sports while you're up there?
I mean, sometimes sometimes we take skis. Like if we're having to do a lot of measurements along like a grid. If it's a really big grid, we'll use a snowmobile and drive it. But if it's small enough, we'll go out there with skis. So we do a little bit of skiing while we're up there. Since we're in the middle of the ice sheet, it's really flat. You can't really do any downhill skiing. It's all just cross country skiing. But we do that. Sometimes if the weather's nice and we've got a bit of a break where we're not needing to do anything, we'll play Frisbee up there. We'll build snowmen or whatever we feel like doing when we have spare time. Unfortunately, usually when we have spare time is when storms are blowing. So it's complete whiteout outside. We can't really spend any time outside. It's not even safe to spend time outside because you can't see more than 5 feet in front of you anywhere. And so we end up spending our free time inside, like in a tent. We'll all be in one big dome tent, and we'll have stoves running, so it's warm enough in there. It's not super warm, but it's warmer than it is outside. And we'll play cards, and we'll read books and things like that, waiting for a storm to pass, because the storm can roll in and last for 3-4 days, and we'll just be stuck in the tents with nothing to do, waiting it out.
Oh man, that's fun. Have you ever found anything in the ice?
Yes and no. So we've done a lot of digging and a lot of drilling and stuff, and usually it's just pure ice because it just snowfalls year after year after year. One time we did drive up, like we were driving, and it's just flat white snow as far as the eye can see, and we see something black up ahead. Like you couldn't quite tell what it was. Just standing up driving a snowmobile, like, what is that up there? And we drove over to it, and it was a bird that had died while trying to cross the ice sheet and was frozen on the surface of the ice sheet. I mean, we didn't do anything with it because it was just a bird frozen on the snow. But there have been other things that people have found. This wasn't something I was a part of, but colleagues from Denmark had a whole mission where there was a plane that had like a jetliner that had an accident, and it actually lost an engine, and the engine fell onto the Greenland ice sheet and then got buried in snow. So they didn't know where it was. And the people who made this plane actually were really interested in recovering that engine so they could figure out what went wrong. So there was this jet engine that was lost somewhere on the ice sheet. And they knew about where it landed, like within maybe a mile, but they couldn't tell you exactly where it landed. Because it wasn't like were tracking the location as it was falling. They knew where the plane was when it fell, but they didn't know exactly where it landed. So they had to go out there and try and find, and keep in mind, when you're out there, it's just flat white snow as far as you can see anywhere, and try and find where there's a buried jet engine somewhere. And what they did is they used this ground penetrating radar. They dragged this radar around, and it would send little signals down. And if it hit a jet engine, a metal jet engine, it would send a really bright reflection back. So, normally it'd just send these little signals down and not get a whole lot back. But if you drove over a jet engine, like a metal jet engine, it'd give a really bright reflection back. So they spent days going around trying to find this thing, and they eventually did. And they had to dig down to it, and they eventually found this jet engine that they were looking for buried in the snow up in North Greenland.
Cool. So we know that climate change is leading to more ice melt. What would happen if all of Greenland, for example, melted?
So that's one of the big things. So Greenland, with all of that ice, it's up to 2 miles thick, covering the entire island of Greenland. If all of that were to melt, sea levels around the world would go up by about 20 feet. So most coastal cities in the world are less than 20 feet elevation. In the cities of New York, of Miami, of New Orleans, have a lot of areas that are less than 20 feet elevation. So the streets would be underwater there if all that were to happen. If all of Antarctica were to melt, that's the even bigger ice sheet, seas would rise over 200 feet. So now that ice has been there for a long, long time, and it is melting, but it's not all going to melt soon. Like, it's not next year, seas aren't going to rise 220 feet. But the really big question, and the reason we're out there studying it, is because seas are rising by just a few millimeters a year right now. But that adds up. You get to do that a few years, and it's a centimeter. And then if a few of those times, then it's a few centimeters, and it's rising faster and faster. So people want to know how fast it's going to rise. And the parts of the planet that are causing seas to rise the fastest are the ice sheets, Greenland and Antarctica. So people really want to know how fast that's melting and how fast it could melt in the future if things get even warmer.
Cool. Well, scary, but anyway,
Yeah.
are there any glaciers in the ocean, or are they only on land?
So glaciers form on land because glaciers only form on land because the ice, it has to have snow building up year after year after year. That doesn't melt. And if snow falls on the ocean, it doesn't build up year after year. You get sea ice on the ocean, where the ocean freezes into a thin layer of ice, but that's a different thing. That's not a glacier. A glacier forms on land. So the snow builds up for hundreds or even thousands of years and compresses into ice and starts to flow out. That all happens on land. So all the glaciers start on land, but some glaciers actually flow out to the ocean, and then parts of it become floating on the ocean. We call those ice shelves, where you've got a part of a glacier that starts on land, flows down onto the ocean, and then a whole piece of it's floating out onto the ocean. Antarctica, around the edges of Antarctica, there's dozens of these ice shelves that feed out from glaciers onto the ocean. So you can actually be walking out on a glacier, and beneath you is a bunch of ice, hundreds of feet of ice, and then it's pure ocean beneath it. There's no land there. And those parts of the glacier do go up and down with the tide because the ice is floating, but it can still be hundreds of feet thick there. So there are glaciers that are over the ocean, but it's connected to the glaciers that are on land. All the glaciers start on land. Excellent question.
Cool. Of all the places that you've traveled for science, what's the favorite place you've ever been?
Oh, I would have to say Greenland. My heart's in Greenland. I've spent a lot of time there. Probably close to a year in Greenland, and I really love the ice sheet. It's weird. It's like you're out there in the middle of nowhere, and it's a completely different environment. There's no trees, no plants, no animals, just flat white snow. You think that sounds really boring in terms of views and scenery, but it's actually really striking. Like, your senses become more attuned. I can detect faint smells in the air. Like, if the weather is changing, I can smell it. I can't normally do that at home because there's so many smells from so many things all the time. Your senses are overwhelmed, but out there it's so stark that you become really attuned. It's slight changes in the light, slight changes in the air and the snow, and it really it becomes its own sort of beauty. And then when I come back to Colorado, which is where I live, where I am right now, then everything feels like I'm in a big rainforest because there's trees everywhere and there's grass and oh my goodness. I really like Greenland. I like it on the coast when we get to go out hiking sometimes before or after campaigns. When we get off the ice, we'll be in the town of Kangerlussuaq, and we get to go hiking out on the tundra, and there will be muskox out there grazing. I don't know if you've ever seen a picture of a muskox, but they got these they're really furry and they've got these horns. They look like something out of an ice age. And there's reindeer out there running around, and you can pick up the reindeer antlers. They lose their antlers every year, and so you can literally just walk around and pick them up off the ground. Um, Sometimes we've taken them out onto the ice sheet with us and then done carvings in them on these off days when there's storms. We'll carve things into a piece of a reindeer antler to take with us when we go home. So I've come to really, really like Greenland and the people. We just visit, but the Greenlanders live there year round. That is one difference between Greenland and Antarctica. Nobody's ever lived permanently in Antarctica. There's scientific bases where people will live for short periods, but there's no towns or cities really in Antarctica. But in Greenland, there are. There are people that have lived there for thousands of years. And so I have friends in Greenland that we visit when we're there. So it's something I've really, really enjoyed.
Awesome. So how long are you on the ice sheet when you're out there? And then what do you eat when you're at the camp?
Yeah, excellent question. So for our campaigns, I've been out on the ice sheet for, some people just fly out with a helicopter and will be there for 4 hours. They'll maintain a station and then they'll fly back to the coast, and that's it. They don't even stay overnight, which is fine. I mean, if you only need to be there 4 hours, that's what you do. We fly out onto the ice and we'll stay out on the ice for about a month. Our campaigns will be 4 to 6 weeks out on the ice, and we take all our food with us. There's nothing, like, we can't just find any food out there. We have to take it all with us. So we take all of these boxes of food, and when we're out there with snowmobiles, we have these huge sleds, these 10-foot sleds behind the snowmobiles that will tow all of our camp equipment and all of our scientific instruments and boxes and boxes of food. We'll have hundreds of pounds of food with us. And so we just pull from our food boxes. We have stoves, these propane stoves we'll set up inside the big tents, and we'll cook our food from them, from the food we've brought with us. And things like canned goods and stuff, one of the biggest challenges is you have to unfreeze everything, because everything's in a permanent freezer out there. When it's -20 or -40 out, everything's completely frozen solid. So if we have like meat out there, we have to warm it up in warm water before throwing it on a grill to cook. So that's one of the challenges, always having to thaw out our food before we can eat it.
Do you have Wi-Fi at camp?
We don't tend to have Wi-Fi at camp. It's hard. It's very expensive to get internet out there. Sometimes we'll have very, very slow internet through a satellite connection, like with a satellite phone. But that tends to be very slow and very expensive, so we don't use it very much. In some more established camps where they have like a permanent base, they'll have internet there. They will have Wi-Fi because it'll have a higher speed satellite connection. Tends to be very expensive, but in these large camps, they'll have it. And so we do get Wi-Fi when we're in an established base. But when we're just out in our camps, we don't tend to have it. We can communicate. I use like a little satellite devices to send out messages. Like I can send text messages to my family at home, and they can message me back. And so I'll turn on that device, sometime during the day and send them a little text and let them know how I'm doing. And we'll call on satellite phones. So we don't have regular phone because there's no phone tower anywhere near us. But we use satellite phones to call like back to the base on the coast and let them know how we're doing, and we'll have daily check-ins by satellite phone. And so we do get information about what's going on in the outside world, but generally speaking, we go about a month with no internet out there. So which is, you don't get as much internet and news and everything like that, but it's also kind of nice to be away from the news for a while.
Yeah, I can really relate to that lately.
Yeah.
So how expensive is it to run a trip out there with your crew?
It's not cheap getting out there. So we take a big military cargo plane out onto the ice, and that drops us off with all our snowmobiles. I mean, it depends on the trip. Again, if you're just going for like out onto the ice sheet for a few hours to maintain an instrument and then come back, like, the biggest thing is the helicopter cost. It might cost you a few $1,000s for the helicopter. When we're going out there for an entire month, it might be anywhere from $100,000 to $150,000 it costs to get a whole team of us out there for a month on the ice. And I don't have that kind of money from my own bank accounts. That comes from the funding agencies that are paying us to take these measurements out there, to do things like help their satellites. So NASA might pay for it, or National Science Foundation. And it's hard to get on these campaigns out in the ice. It does cost a lot of money, and so you have to be doing something really valuable in order to make that worthwhile.
A couple people have asked if you can go fishing on a glacier, but is the ice too thick?
So it's a couple of things. Generally speaking, no, the ice is too thick. Yeah, it's not like ice fishing on a lake where you can cut a hole in the ice and a few feet down there's water beneath. I mean, the ice is hundreds of feet thick, or even thousands of feet thick. And so it can actually, like, people do drill through that, but it takes years to drill all the way through the ice sheet. And even then, with that thick of ice, there's not really anything to fish for at the bottom. It's actually, it'd be a lot cheaper just to go out to the edge of the ice sheet and fish into the ocean from the edge than it is to get underneath all the ice. But there are really interesting, especially in Antarctica, there's a number of lakes that are actually underneath the ice sheet. The ice is under so much pressure that it causes the bottom of the ice sheet to melt. And there's also some places where there's volcanic activity underneath the ice sheet. So you'll have thousands of feet of ice with a lake underneath it. So the ice is actually floating on top of a lake in some spots. And so they've done these drilling expeditions where they take multiple years and they drill down into there, and then they sample to see if there's any like bacterial life that live underneath the ice in these lakes that are beneath the ice, because they would be very, very remote environments where you wouldn't expect things to live, but maybe there are. If there's nutrients down there and a source of energy, maybe things could live down there. So they just wrapped up last year a project in Antarctica and West Antarctica that drilled into these subglacial lakes that are underneath the ice sheet. And it wouldn't call it fishing. They didn't have a pole with a hook there trying to catch anything, but they'd take samples of the water and to see if there's any life living underneath the ice.
Amazing. Do we know the results? Are there bacteria living in there?
I'd have to go check. I don't want to say one way or the other if I'm not sure of that particular project. There's a place in Antarctica called Blood Falls where there's bacteria that live under the ice. It's not way in the middle of the ice sheet, but it's near the edge, but there's bacteria that live in water that's under the ice, and the bacteria have a bright reddish orange color, and when the water spills out off the edge of the glacier, it looks like this bright red waterfall. They call it Blood Falls, and it's all because of bacteria and algae that live underneath the ice a little ways in. So there are places where things do live under the ice. It's hard for animals to live under there because it's under so much pressure that most animals couldn't live, but little extremophile bacteria and algae can, and so they do in places like that.
That's wild. When you're out at night, can you see like the northern lights and like a ton of stars because it's so dark out there?
So it's interesting. Sometimes we do see northern lights. We're there in the spring when it's transitioning from winter to summer. Now we're above the Arctic Circle up there. So in winter, it's pure darkness in the middle of winter. And we're rapidly transitioning to summer. Usually when we're done with our campaigns in May in Greenland, it's 24-hour sunlight. So even at midnight, the sun's still up. The sun's just circling around the sky during the night. It's brighter it's higher up in the sky at the middle of the day at noon, but it's lower in the sky at night, but the sun never really sets. But at the very start of our campaigns, we still get a few hours of darkness every night. And yeah, sometimes if you go out, you can see the northern lights out there. So if you're there in the winter, sometimes you see some really spectacular northern lights because it's dark all the time. And so if really good ones show up, you can just look outside or walk outside and see them.
Cool. Do you ever find rare rocks when you're out on the ice sheet?
So on the ice sheet, we don't end up finding any rocks simply because we're standing on 2 kilometers of snow, and we'd have to get down beneath that to get to any rocks. But when we're off the ice sheet, when we're on the edge of Greenland, we'll get to drive out and then walk out onto the edge of the ice sheet. And the ice, as it's flowing, will dredge up rocks, like it'll scrape the rocks it's flowing over and bring up all these rocks from underneath the ice sheet and spit them out onto the edge of the ice. When the ice ends at the edge of the ice sheet, all the rock that's been flowing with the ice that it's been dredging up from the bottom will get spit out onto the end. It'll form these big piles we call moraines. It's these huge, long piles of rock. And it's very cool walking around on top of these moraines. You can pick up all these rocks that the ice sheet hundreds of years ago dredged up off the bottom of the ice sheet on the rocks it was flowing over. And you'll see all these very cool rocks with like little garnet crystals all through them, and all these weird types of rocks that are very, very cool. And so we'll go around just picking out cool looking rocks sometimes on the edge of the ice. Not so much in the middle of the ice when we're out there doing the science, but on the edge before or after a campaign, we'll get chances to do that.
Cool. So what color are the glaciers in Greenland?
So glacial ice, when we're on the snow, it looks just white, like snow. It's just like snow that anybody else has seen. But the ice itself is really this iridescent blue. And the snow is too, actually. If you dig like a snow pit down, and we've done experiments where you dig two pits next to each other and you got a layer of snow, like a wall of snow between them, and you put a tarp over one and you can see the light coming in through the snow. The ice has a blue tint to it. So when you get light going through enough snow and ice, it will form this really, really bright iridescent blue. And it's really, really beautiful. When you get to the edge of the ice sheet where there's not snow anymore, but it's melted down to bare ice, it's this really bright glacial blue ice, and it's just absolutely dramatically blue. It's beautiful.
That's awesome. So what's the longest you've ever stayed in Greenland?
The longest I've gone in Greenland has been about close to 2 months in Greenland. That's my longest stretch. There are other people who, again, take measurements throughout the whole winter. They'll stay up there on the ice sheet for 6 months. And they'll, through an entire winter season, they'll go out every day and take a measurement. And they keep experiments running through the entire winter up there. So that's not, my 2 months isn't a record, but there have, but that's about how the longest I've spent in Greenland personally.
Cool. What's the most dangerous situation you've ever encountered during field work?
It's generally the cold and the storms that really get us into trouble. And we have a lot of safety precautions. So when a storm is really howling through camp, it's blowing snow everywhere, and it's a complete whiteout. So we have to set up lines and flags between every tent just so you can make it around camp, because you can walk between the tents and be in a spot where you can't see either tent. You can't see the tent behind you. You can't see the tent you're going to, and you can get yourself lost very easily, especially if you like drop a glove and it blows away in the snow and you go chase after it, and then you look back and you can't see camp anymore. And if that happens and you can't find camp, you could freeze to death. Even if camp is just 100 feet away, you don't know where it is. So we always have to carry GPSs in our pocket when there's a storm. Every person has a GPS in their pocket with a little flag of where the mess tent is, the main tent in camp. So that if you get lost, you can actually just follow your GPS back to camp and find the mess tent. We've had issues where a storm came up while we were driving snowmobiles, so we didn't have a camp. We had broken down camp, like taken down all the tents, packed them all up that morning, and we're driving. And then a storm came in unexpectedly. Like, we get the weather forecasts out there and we try and do it just on clear days, but sometimes there's weather changes and sometimes it blows in. And so we've had periods where we're out on snowmobiles driving and we get these whiteout conditions and you can't see anything. And it's very hard to set up a camp in blowing like hurricane force winds and blowing snow. The most dangerous situations we've had have been when people go out and aren't prepared enough. Like, they go out for a day to take some measurements. They'll drive out 20 or 30 miles from camp, take some measurements for a day, drill a core or something like that, and then come back. And it's beautiful in the morning, and they didn't take enough stuff. So they didn't take like the really big heavy coat. But then the weather turns and then they put on everything they've got and they're trying to get back safely, but they're really, really cold by the time they get back to camp. We have very specific rules about if you drive further away from camp than you can walk back, then you have to have like an overnight bag that has a tent, an extra tent and sleeping bag and stuff in it, so that if you have to set up camp, if your snowmobile breaks down or something, you can stay out there till somebody can come rescue you. And you also have to bring enough for the worst weather you could encounter, so that so to keep people from getting into these dangerous situations, because we've had people get frostbite I've gotten frost nip where it's not completely frozen way deep, but just the surface skin is frozen, where I had like a gap in my helmet where like a line on my neck gets slightly frozen, and then it turns black, and I've got this black line on my neck for a few weeks. It goes away as long as it wasn't too deep. Frostbite is when it's really frozen the entire depth of the skin, and then you have real issues. I've had that a few times, this little frost nip in places. And we have had people get hypothermia if they were not quite prepared enough, and where people have to help them warm up and get, because they can't do it themselves anymore. They're just very loopy and are too cold. So those are the biggest dangers to us out there.
Oh boy. Okay, so we try to keep these at 45 minutes. So I have 2 final questions for you.
Okay, I'll try and keep them quick.
Okay, the first question is, what do you wish everybody knew about glaciers? Do you think like one thing about your work that you wish everybody knew?
I wasn't prepared for that one. That's a great question. I wish that everybody knew just how much ice there was out there. Over 90% of all the fresh water on Earth, not counting the ocean water, it's salty, but the fresh water that's in lakes and rivers, over 90% of it's locked up in ice, mostly in Greenland and Antarctica.
That's a great one. I did not know that. All right, the second question is, what's one thing that you wish everybody knew, completely unrelated to your work? One thing in the whole world that you wish everybody knew.
Just a random thing that I wish everybody knew.
Yep.
Okay, I was prepared to talk about glaciers, but I guess if it's not related to my work, one thing I'd like everybody to know is that if you're wanting to do work like this, like to be a scientist, it's not really a measure of how smart you are. People think you have to be like super good at math or super good in science classes in order to do science. And really the best scientists I know aren't the ones who like did great in school and got straight A's. There are a lot of great scientists that got straight A's, all through school and stuff. But really creativity and curiosity, just always wanting to know what's going on and what's causing it, is like the biggest thing to be a really successful scientist. And I want everybody to know that. Some of the best scientists I know like failed physics when they were in high school and college, and but then went on to be great scientists just because their drive and their curiosity fed them through the whole way.
I completely co-sign that. I think that's a great piece of advice. Okay, well, thank you so much for joining us today. We learned so much of cool stuff. Thanks everybody for joining us. We're gonna have another one of these tomorrow. You can always check our full schedule on our website, skypeascientist.com, and then you can click events and then Skype a Scientist Live. You'll see everybody that we have coming up. We have one every day this week, and then we have almost every Monday through Friday for the next couple weeks while we're all holed up inside. Again, we are a 501c3 nonprofit and completely rely on donations to keep our program going. So if you can support us, we'd really appreciate it. Even a couple bucks is really helpful when everybody pitches in. That'll be paypal.me/Skype a Scientist or patreon.com/Skype a Scientist. Thanks again for joining us. I hope we see you all later this week. Thanks, Mike.
Bye.
Bye. Thanks, Aaron.